For T18, they give us the graph of x, or of f, and part A tells us that g of x equals the definite integral from 2 of x for the function f of t, and we are supposed to sketch the graph of g. So they give us g of x, and we find what those points are from 2 to x. So from 2 to 2, the area under the graph is 0, and for g of 1, the area between the graph, which is negative because you're going back, and since the area under the graph is under the x-axis, it is also negative, so therefore the negatives cancel out, and it is estimated to be 2.7. G of 3, which is from 2 to 3, is estimated to be about -7. We find G of 4, which is from 2 to 4, by adding the previous area, which was 2 to 3, plus the area, which would be from 3 to 4, and we get -0.1. Same thing is done for G of 5, and we get 1.1, G of 6, 2.3, G of 7, 2.9, G of 8, 2.2, G of 9, -0.5. So then we graph those values, and we get a graph that looks like this. And this graph makes sense because as the area is negative here and positive here, the graph is decreasing and then increasing for that, and then decreasing as it starts to decrease. The area is negative again. And then part B tells us to find the derivative of h of x, and it is given here, and find the derivative at 3. So, due to the central limit, the fundamental theorem of calculus part 2, that says that the derivative of an integral is the same thing as the function with the top boundary placed in as the value. So therefore we get h prime equals f of 3 of x minus 5 times 3, because that's chain rule. And then we can plug in 3, and we get f of 4 times 3. Now on the graph, f of 4 is about 1. So then we can plug that back in, and h prime of 3 equals 3 at that